All right, part 3 for environmental analysis 2. This will be the base file. You can take a look. We brought in the work that we did a couple weeks ago, and we're going to start applying some of this stuff to a kind of a more architectural example. So going a little bit beyond just graphics and trying to now see how some of this output could be applied directly to some design decisions. All right, so remember that when you open this, you have to first turn this on. All right. And once that's done doing its thing, feel free to run and turn that to true, the radiation analysis, and you'll be up to speed with where I'm at here. All right. Okay, so I'm going to just turn off that preview and have a look at what we've got coming out here. Yeah, we're going to work with mostly everything coming out. We're going to work with two things: the radiation result and the radiation mesh. Okay. Okay, so let's start with the mesh, and there you go. The radiation mesh will show us the colors, which is pretty nice. And this is assuming a north in the positive Y, and you see why, in this area from the southwest, we're getting a lot of solar exposure, and then over here, up in the north, we'll get a lot less throughout the year, right? And that's pretty obvious, in Buffalo at least. And coming out of here is overall mesh, but we know that it's disjointed because it's not touching. So, and we're gonna wanna make changes to this stuff at the level of individual mesh faces. So we're gonna go over to mesh and utilities, and you should be able to find the disjoint mesh here. And that's gonna look like it's the same if you turn off that preview especially, but if I hover over, you can see that now all the pieces, the 1193 pieces, are separated from one another, which is good. And for this, so we're gonna walk through 3 different examples for how to play with this, all right? The first one's gonna be this: we're gonna apply either a frit pattern or a perforation pattern. And we're gonna be able to kind of swap between the two ideas. So we're gonna put a bunch of little circles on these panels, and the number of circles is going to depend on the solar radiation. Okay. All right, so I'm going to use a little handy kangaroo component to get started. I'm going to go to kangaroo 2. You can see in the, where is it? I guess it's going to be under mesh, refine. Go ahead and refine these meshes to a degree of 3. So I'm going to put a panel in here. And that's going to look pretty dark on my screen. I got a lot of mesh faces now, so I've added a lot of resolution to each one of the meshes. And that's because what I want to do is put a circle at all the center points of those faces, those new little faces. Okay, so I'll zoom in a little bit. We lost our colors, but we'll get them back, so don't worry. We're going to go to mesh again, and we're going to go to analysis and face normals. And that's going to also give us our center points. Turn off that preview. All right. Now these center points are going to be used to as the center point of our circles. Okay, and really handy. The normal is what we're going to use to orient them in space, so that the circles are actually drawn in 3D on the mesh panel. Okay, so that they're not just drawn however. We want it to look like they're attached to the panel, or cut away from the panel. All right, so we're going to do some random reduction, kind of like what we did in the first example. First thing I'm going to do is start setting up that stuff. So get rid of the boring stuff. So I'm going to go to sets. I'm just going to go over to tree here and do this flatten tree. I think it's a little bit easier for you guys to follow along when I'm not using the arrows. And here I'm going to take the radiation result, and I'm just going to flatten that into a single list because I need to start setting up a gradient overall, and then I can put it back into its into that data structure later, and we'll talk about that when the time comes. So we'll go to math, min max. This is the kind of theme of the day here, this remapping stuff. So if you're getting used to it, go ahead and start throwing in those this kind of remap process, as you can see here. And now I need to set a custom target. So for this, I'm going to grab a construct domain component. The first number in here is going to be the number of, you can see here, for each mesh panel, I've got 64 faces. So I'm just going to type in 64. Because I know this is not something that I care to change. This is a density that I like, so I'm not going to change it. If I did change it, I can always reduce this number. And then I'm just going to put in 0 here. And that'll be our target. And what this is going to do is tell us how many things we want to remove. Okay, so it's either going to remove 0 circles or it's going to remove 64 circles, making the panel solid again. Okay, so that's what we're setting up here, and we're going to relate it to all these values. And you can put a round on this. The components will probably do it itself, but I'm going to type in round, double click, type in round, and I'm just going to round this to the nearest number, which is good enough. And then I'm going to head off to sets. Sorry, where is it? Yep, sets, and do that random reduction again. Right? You might remember that from before. Okay, so let's take a look here. If we're going to randomly reduce our center points. Now look, the data is kind of important to take a look at here. So we've got 1,193 paths. Each one of those paths have 64 faces. Okay, so it's basically on the left is counting all of the panels themselves, the diamond-shaped panels, and on the right is how many little faces you have, or how many little center points you have on each one. You need to keep that data structure. So let's go ahead and plug in, because this is going to be what we're going to randomly reduce, but we're going to reduce it not as an overall set, but from each panel. Okay, and the effect will be overall anyway. Now, we can't use this because this is a single, right? If you plug this direct in, you may crash the computer, or it's going to take some time to calculate, because you're going to basically be applying all 1,193 things to a whole lot more over here, 76,000, right? And that's probably going to end up result in a crash computer. So here is where you want to do a grafting, and you can either right-click on this and go to graft, or you can use this graph tree component. It's up to you. I'm going to do the right-click because it's a little easier for me. And now we can go ahead and plug that into R. And you're going to start seeing a kind of a reduction of those points. And it's going to be hard to visualize what's really happening here until we start adding geometry to it. So let's turn that off for now. And let's do the same thing with these normal vectors. All right. So go ahead and copy and paste that. And then the L receives the normal output here, right? So now we've got these two things matching up. Now we can use these to draw circles. So what we're going to do is, and here's where we can turn off our meshes, right? Let's do that. We're going to go to circle, primitive, circle C and R, circle center. Our centers are here, and that's going to go wild for a second. The normals are here, and that's going to orient everything properly, and our radii are huge. So we got to drop that down. So make them small enough so you can see it. I have 0.025 from a little experimentation for this file. I think it worked pretty well, so I'm going to suggest that. And now we can kind of get a good sense for what's happening if we zoom around. So the panels that had the most solar exposure are going to get the most circles. They're going to have the least reduction. So it depends on how you think about it. So if we think about this, you can see it here, the reddest ones from before are and we can turn those back on to give you an idea. Let's turn these back on. The reddest ones, right, are going to have the most circles. The bluest ones receiving the least light are going to have either none or just a couple. Now, in this case, what we might be talking about is some kind of frit pattern, which is a kind of is applied to the glass itself so that it blocks the sun. Now, in that case, it makes sense. So the higher density of opaque frit, the less light actually comes through, and the less solar radiation could affect the interior, and vice versa. So in this case, because we're receiving very little light, you want as much of it to come through to kind of heat the space, especially in the winter. All right, so these are kind of basic concepts. Now, if you're thinking about it in a different way, if it's a perforation, you probably want the opposite, right? Because if it's a perforation, you probably want this to let the least amount of light through, kind of block it to keep things cool in the summer. And over here, you're going to want more light in to warm things up a bit in the winter. So in that case, it's just as simple as reversing the domain here. Okay. So now if it's a perforation, these are highly perforated panels letting a lot of light through, and these are solid panels over here blocking the majority. All right. Now, while we're using custom colors, we may as well turn these meshes off and just look at the colors on the circles themselves. So let's go ahead and grab our gradient. We'll set the colors using the same preset that they use in, in Ladybug. I could deconstruct this here domain to figure out what my max and min is. So I'm just going to go to math, deconstruct, and this will give me my input into L0 and L1. And now my T parameters are going to be a flattened version of this. I know this is a little bit confusing, but when you're applying an overall gradient, it does need to be a separate single list, which we could then regraph later before it heads off into our geometry. I know this is a bit strange, and but some components are just going to require this kind of workflow. All right, let's bring this over here. And I'm going to set up a custom preview. So we'll go over to display here, custom preview, the geometry of the circles, turn them off. And now before I do anything, I can't go plugging this in because remember it's a flat list again. So we'll go to sets, grab this little graph tree component. Looks like a little leaf, little leafy structure there, and you can plug those into the shaders there. Okay. So let's see. Yeah, I've got the opposite of what I want here. Red should not be over here because that's not what the data says. Actually, this is the most solar exposure, and we want to. So let's just swap these. All right, like that. And now, yeah, the most solar exposure. You can see the least number of red dots means the more exposure that's being blocked. If this is perforation, over here we're getting nice, cool. Less light and more northern light, and we want to let as much of it in as we can. So this is a higher density of perforation. But if we're thinking about it like a frit instead of a perforation, again, you go back, swap these, and there you have it. Right? So you're able to, look at a couple different options, either a frit pattern or a perforation pattern, just by making a really quick switch here. GH. All right, and the overall effect is very beautiful, I think. Hopefully you guys can see that coming through on the screen. I know the recording might not show the blues very well, but you should be able to see it on your screen better. All right, so that's a little bit of part one, and we're going to try another version of something similar, but instead we're going to apply it to a kind of a sun shading element instead of just a frit pattern. All right, so I'm going to turn off this here, and we can label this perf frit, something like that. Cool. All right, I'm going to head back and start with these meshes again over here, all the way back. Okay, so go to mesh, and we're going to grab this mesh edges component. And then I'm going to measure how long each one of the edge lengths are and sort them, okay? This will all become a little bit clearer why we're doing this a little bit later. So take this, measure the lengths, turn off the preview, get into the habit of that. We're going to go to set, list, sort list, not tree. We're sorting the distances, and we're going to reorganize the lengths, and we're going to reorganize the lines themselves. Let's go back over to list item and isolate each one of the four from one another so we can select them independently. All right. Now here's a nice little trick. What we're going to do, what I want to do is start drawing lines across, almost like these kind of vertical or horizontal sun shading elements, stick elements, kind of linear element. Think about it like maybe a piece of wood or maybe metal. But what I got to make sure is that I'm drawing them across and never to adjacent sides. And because all of these diamond shapes are different, we have to set up some kind of a rule for that, because the longer edges are not going to be the same all the way around. So it's not always these two, for example. Sometimes the longer edges are adjacent to one another. So we need to come up with a rule to prevent that from happening, so that when we connect the dots, we don't have any weird connections. All right, so this is a nice little trick that I worked on. That I think if you take your time with it after the tutorial or something, you might be able to kind of absorb it a little bit more. I'm going to go a little bit quickly just to keep this moving. And remember that something like this is kind of custom to this. So if you try to apply this to a different project, it may not work. All right, so remember that sometimes there are one-off solutions here, and it's because of the very specific geometry that we're working with. All right. So first, I'm going to do a merge of the first three, because these are the shortest three. The longest one is always the last one on the list, because that's the way the sort works. Okay, so I'm going to first compile the short three into their own list. And I want to isolate the long one, so I always remember that that's the long one. Okay. Now I'm going to find the center point. So I'm going to go to curve, grab this little point on curve, and find the center point on all those short ones. And I'm going to go to vector and go to point and pull point. The pull point component is very cool because it gives us distances that something is away from something else. So the geometry that's going to pull is going to be our long curve, the points that we're going to bring in here, and we're going to use these distances to figure out which one is the one that's across the diamond, never adjacent. Okay. So it's a nice little trick to fool Grasshopper into giving us what we want. And as I go, I'm going to make sure I'm turning off previews, because we want to make sure that our results are correct. All right, now I need to do a sort, so I'm going to go to set, list, and sort. The distances are going to be sorted from small to large, and I'm going to reorganize the original set of points, the curves. All right, so now these are organized from small to large. And I need a set list, and I'm going to select the longest one of those, or the furthest one, sorry, the furthest one away. And to do that, I'm going to plug this in here, and then I'm just going to right-click on this and reverse it. All right. And that's going to give me the this should give me the one that's furthest away from this one. And now if I take a look, if I zoom in, what I should never be seeing is in any one of the diamonds an adjacent two curves. There should always be a curve that's on one side or the other, right? And that looks like it worked very, very nicely. Okay, couple more things before we start connecting the dots here, and it's to make sure that the lines are going to be in the right direction. And I'll show you what I mean by that. So let's go to curve, division, divide curve, because we're going to need some division points here. The first one that we're going to divide is, I'm going to put that up like this, free up some space. The first curve is the long one, all right? And I'll turn that off. And I don't need to, well, I'm going to make it low for now so we don't have as many points on screen. So I'm just going to plug in 5 here, all right? And then I'm going to go ahead and copy and paste that and go with that curve as well. We can turn off these previews because they get a little distracting. And then let's see what happens if we connect the dots from point to point, all right? Yeah, pretty good on a lot of them, not working on a lot of the others, right? And this is kind of what I meant. So in this case, the lines are in the same direction. We get a direct, we get a direct hit. In many of the other cases, the lines have to be flipped in order to get this pattern to correct itself. All right, so what we're going to do is we're going to go to, I think it's in utilities. In curve, there should be a flip curve. Grab that, And it doesn't matter which one you flip here, so I'm just going to flip the second one that we found. You can also flip the long one. It doesn't actually matter. One of them has to be flipped. And the one that's being flipped has got to be organized by the other. And that goes into G. One of them has to be the guide curve. And we're going to use one, and we're going to use this one to guide all the rest of them to make sure that they all match the guide. And we're doing that within the data I guess set that's relative to each one of the individual panels, not the overall set. Okay, and that's why grafting is super nice in this case. So now if we plug that in, you can see we've got a fix for the problem. But what's interesting, is that given the little rule that we set up here, you're not always going to get a continuous pattern of sun shading. Up here when the diamonds are in a certain proportion to one another, it's vertical, but that switches based on the rule that we set around the bottom somewhere. And to be honest, I actually think it's kind of nice. It's a pretty interesting effect for me. I don't think it really matters much in terms of the solar performance, right? I mean, it's still gonna, a little bit maybe, but because these are not perfectly vertical, they're still gonna block light in a similar way. And something nice happens at the front. Now they start to kind of interlock into one another, the different directions. Super cool. So I think we get a pretty nice emergent effect from this that we couldn't really design in advance. You could have this idea, suppose, and start assigning it to particular mesh faces, but what I like is that we've applied a parametric rule, and from that something emerges that we weren't expecting, or that we weren't expecting. And I think you should be conscious of these moments and decide on whether or not it's good, or if you need to fix it. And in that case, we'd have to think about modifying this system. I do want more, though. I want more lines, so I'm going to plug in 15. I want this to be pretty dense. So let's do that. Let's increase the density. All right, now let's apply the same kind of thing that we did before, which is this kind of random reduction based on the radiation results. All right, so I guess we can copy and paste this and make some changes so we don't have to remodel everything. All right, so let's bring that over here, because the flattened data is still the right stuff. But I am going to make some changes to this. So I'm going to, we can leave that at 0. I'm going to take this out, okay? And I'm going to either add or subtract. So in this case, what I'm going to do is subtract. Use math, go to math, minus, and I'm going to subtract from this value a certain number to set a maximum for how many things we're going to be able to remove, how many of these elements we can remove. All right, and that'll go into my A input here, and then I'm just going to plug in, let's say, a 1 into B here. And you can experiment with different versions of this, but I like this result. And I'll show you exactly why when it's done. All right, now we can grab that random reduce. So we'll go to vector, grid, set, sequence, random reduce. The lines are what we're reducing. The number of things we're reducing is based on this little setup that we just did here. I'm going to turn off those, and you can see I've started to already see some results. So let's go ahead and check that out. Up here, where the sun is at its most extreme, we've got a lot of shading. Makes sense. Over on this side, of course, we've got very little. And the reason why I did this was because I never wanted to remove more than 2 remaining. So I always wanted to make sure that there was at least 2 SunShader elements. So if I increase this value to 2 or something like that, I will always add 1 more. If I made this 0 and I removed, you'll always get at least 1. Now you could remove all of them if you add 1 here. All right, so let's talk about that for a second. So if we added 1 to this value, instead we plugged in 16, a lot of these would go empty, which means you'd have full-on glass. So it depends on what you're looking to do. I thought it would be nice if there was at least 2 elements on every glass panel, and in that case you can start seeing this nice little kind of shifting of, these overall sweeps of, of the sun shading elements. And then how that kind of changes direction here is actually kind of cool. So let's add some color to it. All right, so we can grab a gradient. Let's make this a little bigger. Grab our gradient, and we'll put a preset on that, maybe a little different one. Maybe I like the green one for this. All right, let me figure it out. All right, yeah, so similar to what we did last time, we can deconstruct this domain, and that will be our start and end bounds. And the numbers themselves are a flattened version of these, so we'll go to sets, get that flattened tree trunk there, and pop that in like that. Good. Now we need to do a regrafting once all that data is nice and set up for us, and get a custom previewer. So go to display preview, lines, and color. Turn these off, and we have a very nice effect here. You know, darker green, fewer elements, and lighter green when the solar radiation is a little higher. Of course, you can compare this back to the original data if you grab this preset and reverse these numbers. So that'll get you back to the original data if you want to make a direct comparison, you know, to that. But I think in this case, I think something pretty nice can emerge as a kind of an architectural theme, you know, which is still related to the analysis, but doesn't necessarily have to, you know, be organized in the same way in terms of solar radiation. In this case, we could just be showing how much, let's say from black to white, we could be showing how much or how little light comes through, and at least suggesting that. So over here, it's quite bright. Over here, it starts to darken off a little bit. And that's just the density of lines. Very nice. Yeah, like this. Okay. So we can go ahead and hover over this and name that shaders. Okay, I'm going to do a couple more things, and then we'll wrap this one up. Let's apply, remember we did some rotation to all those panels in the first one, and we applied color to those rotations. In this case, we're going to take the data and force that to affect the rotation angles. Okay, and then after that, we'll do a little bit of a modification to the panel geometry itself. All right, so that'll be the last two things. To get this one started, I'm going to bring these meshes out a little bit. I want to set up a new workspace, and I'm going to work from these meshes again, so I'm just going to bring these out, turn off that preview, and I'm going to start working up here. Okay. And all right, so let's, what we need to do is, for this example, is find the 4 vertices. So I'm going to go to Mesh, deconstruct Mesh like this. The 4 vertices are organized really nicely for us. What we then need to do is go to Set List. There you go. And what we're looking to do here is we need a rotation axis, right? Because you remember doing this from the first time around, just that before we did it with surfaces. So there's my rotation axes, okay, from those 2 vertice points. Okay, and let's see, this data, I think that might actually be fine. Yeah, I can flatten it. So before I do that, I'm going to head over to, I like to kind of, you know, sometimes work backwards, so I'm going to grab the Euclidean rotate 3D component. I'm going to set that to degrees. This, you know, should be kind of familiar. And I do need a center point on all these, so I'm going to go ahead and I am going to flatten this because I think that might work a little bit better. And I'm going to find the center point because we do need to also set that. So let's put that in, and then this is going to go ahead and be our axis like this. Okay. Now all we got to do is set up our geometry and our custom angles, right? And the angles are going to come from this radiation result, right? So you can go ahead and copy and paste all this stuff, bring it up, and we're going to set a different domain in here. You can throw that in there as the starting, and then set your max angle. I'm going to say 45. And we're almost ready. Let's just get the geometry. Where's our meshes? There they are. So let's put those in. And let's go ahead and apply those rotations. And it's pretty cool because we're working with meshes, we don't actually have to add a gradient color because the meshes themselves have already been colored, which is unique to meshes in Grasshopper. They don't have to be custom previewed in the same way when it comes out as a radiation mesh from Ladybug, I should say. All right, let's take a look at what we've done here. We've got our max rotation angle set to where the solar radiation is the highest. So this might be related to something like ventilation, right? So when it's pretty hot out, these panels might operate so that maybe there's a sensor, or maybe they're just operated so that these open more and it gets out some of the warmer air that's being heated up from the solar exposure. So you can think about it that way in this case. The rotation angles might be related to actually venting. And over here, we can see that throughout the year, we're just rotating these a lot less. We just don't need to vent these as much. So this could really reduce, this kind of analysis could reduce the kind of mechanical systems that you actually have to apply to your facade, reducing the cost quite a bit. You could be saying that instead of all, almost 1,200 panels, we're actually going to have operable, 600 of them or something in this area, right? And having this kind of analysis is very helpful for making that kind of call. All right, so there's a nice example of rotation being applied to the data. So I'm going to move this up, call these venting. And then the last one is going to be a total change of the geometry of the panel itself, right, as a way to experiment a little bit further with this. I could reuse these components, so I'm going to bring these down here. Get that out of the way up there. Instead of this line, actually I want a different kind of line, so I'm going to go to curve, and I'm going to grab the other two outputs, right, I and 2. Now these are the horizontal ones. I'm going to evaluate that, so I'm going to go to curve, evaluate curve, you can see it here. And you can copy and paste this stuff. Again, this is the stuff that comes out of our radiation numbers, right? These are the results. We're going to remap this, though, between, let's say, 0.1, something smaller, 0.1 and 0.8. So it's got to be between 0 and 1 in this case. Because this is how the parameterization works along these lines. And what I'm really going to do is I'm just going to locate a point. I hope I didn't do anything stupid here. Hang on. Okay, 1 second. See, luckily I didn't crash, but you can see that I've got way too many things coming in, and that's because I've got this mismatch here, right? Chain link line to just a double line, and so what we want to do is disconnect. Before we do anything, right click on this and make sure it's grafted, okay? And now we can plug that back in and it's nice and clean. And you can see that if I turn these lines on, the location of that point is now moving along the line in a gradient. Where the solar radiation is the higher, the more left it'll be. Where it's lower, the more right it will be. And you'll see how we're going to use that. So we can turn that off. All right, let's swap that point with one of the other vertices and recreate the mesh. Okay, so we're going to go to Sets and Replace Items. Okay. Now, the set that you're operating on here is the original set of vertices. The items to replace with are the new points, and the index here is going to be 0. This is not always the case. The reason why it's 0 is because when this is at 0, when this evaluation is at 0, it's closest to the point at 0 index, and that's just by dumb luck. But if that's not the case, you can update this this index, and you can adjust. The consequences of this being wrong are not that big. You'll just draw a different kind of result in the end. So we replaced what used to be we basically replaced that value. It's actually not, sorry, it's not by dumb luck. It's because I is the starting point of this line. If I was not the starting point of this line, this would have to be updated. So let's say if it was 3, then this would be 3. If A was 2, this would be 2. Okay? Don't let it confuse you. It's just an example. And here we're going to go to Mesh and wrap this thing up and rebuild our mesh using Construct Mesh from the Primitive tab. Plug in our vertices, and we can add the colors if we like from the color output of the Deconstruct Mesh component. So let's put that in. And then let's turn off all these points here because they're slightly distracting. And let's zoom around. Okay, on this side we start to transform from the original diamond to kind of a triangle. A perfect triangle will be like when it's right in the middle, probably yellow. As the solar irradiation heats up, we remove a lot of our panel, and as we come around, they transition from that shape to the diamond again, all the way until it's almost a full panel. Now to make that change, you can make this 0, and that'll go back to the full diamond at some point. I thought it was kind of nice for it to transition to, never back to the full diamond. Now, you can imagine, I'm not sure, this might be, if this were a glass panel below, these red and blue and yellow parts, they could be like a metal panel, maybe that gets applied, and in that case, we'd be blocking a lot of the light on the north, which is probably what we don't want to do. So maybe we can reverse these and instead do the opposite. So here, we can have this little SunShader thing, or maybe even just an architectural element. I don't know what to call it really, but here we'd be still letting a lot of light through because this opaque piece is not blocking too much, but over here it's going to block a lot more. So it's another way of adding, it's another logic to add sun shading based on the overall solar radiation that's coming out of Ladybug. All right, in this case, we're actually using it to affect some geometric change along the whole course of the skin of this building. All right, so that wraps us up for this example, and we can go ahead and name that one as well. Something. And you've got your 4 different results that you can cycle through. Okay, so there's one. There's the venting result. All right, the perf, and maybe my favorite, the shaders. All right, so it's pretty nice. It's a nice way of, looking at a couple different options and having a discussion with your collaborators or your faculty. Okay, have fun with this, and think creatively about how you might start using environmental analysis data to meaningfully affect some of your design decisions in terms of the way the building performs. Try to think about it not so much as a purely aesthetic decision, but think about how these kind of changes actually make the building operate better, based on the surrounding environmental conditions. Okay.